Hey everyone, and welcome back to the deep dive. You know we love getting your research requests, and this one is all about MySQL's Change Buffer.
Oh, yeah.
You've sent us a great piece by Kedar Vijanaperkar called MySQL Change Buffer Refresher and FAQ,
Mhm.
and I'm excited to unpack this with our expert because understanding this feature can really unlock some serious performance gains in your database.
Absolutely. It's one of those features that works behind the scenes, so understanding what it does and when it's most effective can make a big difference in how you approach database optimization.
Oh, okay. So let's dive right in.
Yeah.
What is this mysterious change buffer and why should we care?
Think of it like this. You have a to-do list,
Okay.
but instead of tackling each item right away,
Yeah.
you group similar tasks together to do them more efficiently later.
Okay.
That's essentially what the change buffer does for MySQL.
Okay.
It optimizes changes to secondary indexes by temporarily storing them and applying them in batches.
So it's like having a staging area for changes instead of updating the indexes directly?
It's exactly. Updating secondary indexes directly can involve a lot of back and forth within the database,
Hmm.
especially when dealing with large data sets.
Right.
The change buffer minimizes this by batching those changes,
Okay.
sort of like optimizing a delivery route to avoid unnecessary trips.
That makes sense.
Yeah.
So by reducing this back and forth, we're
Yeah.
saving time and resources. Yes.
Precisely.
Huh.
And this is particularly beneficial when dealing with situations where your data set is larger than your InnoDB buffer pool.
Hmm.
That's the memory MySQL uses to cache data.
So if my database is working with a lot of data that doesn't fit in memory, the change buffer steps in to help manage those secondary index updates more efficiently.
Exactly. It's like having an extra storage space when your main warehouse is full.
I like that.
Now, the article mentions three key components of this change buffer: insert buffering, delete buffering,
Okay.
and purge buffering.
Okay, let's break this down. What's
Yeah.
happening with each of these?
So insert buffering handles changes from insert statements. Instead of immediately writing these changes to the secondary indexes,
Right.
they're held in the change buffer, streamlining the process. It's like taking notes before incorporating them into a larger document.
And what about delete operations?
Yeah.
Does delete buffering work similarly?
It does. Instead of removing index entries right away,
Okay.
delete operations are marked for deletion in the change buffer.
Okay.
This minimizes the immediate overhead of purging. Think of it like adding items to a to-be-deleted list rather than hitting the delete key for each one individually.
So both insert and delete changes are being staged for later processing.
Right.
What about purge buffering then?
Yeah.
What does that do?
Purge buffering is the cleanup crew. It helps efficiently remove those marked index entries,
Okay.
keeping everything tidy and optimized.
Gotcha.
It's like emptying the trash bin once it's full.
Okay. So we have these three components working together to make changes to secondary indexes more efficient. Now, if I wanted to actually see this change buffer in action to see how it's behaving, are there ways to monitor it?
There are. MySQL provides configuration options and commands to monitor the change buffer.
Okay.
You can use the entity change buffering setting to enable or disable specific types of buffering.
So we can actually fine-tune which aspects of the change buffer are active.
Exactly. And to see it in action,
Okay.
you can use the show engine InnoDB status command.
Okay.
This gives you a real-time snapshot of the change buffer's activity, including details like how much space it's using and how many merges have occurred. It's like peeking under the hood to see the engine running.
So this command gives us a glimpse into the inner workings of the change buffer.
Yeah,
In the article, there's a section showing some sample output from this command.
right.
It mentions things like iBuf size 1, free list len 0, seg size 2, 0 merges. What does all that mean?
That output is like a diagnostic report.
Hmm.
It tells you how much of the change buffer is being used, how much free space is available, and the number of times the buffer has merged changes with the secondary indexes.
Okay.
It helps you understand how actively the change buffer is working.
Okay, so by looking at this output,
Yeah.
we can get a sense of how busy the change buffer is
Right.
and whether it's effectively managing those secondary index changes.
You got it. And now that we have a basic understanding of what the change buffer is and how it works,
Mm,
let's talk about when it really shines.
yeah.
When would we say,
Yeah.
yes, this is a perfect scenario for the change buffer?
All right, let's talk about when it's time to let this feature shine.
There are a few key situations where the change buffer is incredibly beneficial.
Okay.
Firstly, remember when we talked about the dataset exceeding the buffer pool?
Yeah.
When your dataset is larger than the memory MySQL has available,
Mm-hmm.
that's when the change buffer's ability to stage changes and reduce disk operations becomes a real performance booster.
So if I'm working with a massive database that doesn't fit comfortably in memory,
Yeah.
the change buffer is like my secret weapon for keeping those secondary index updates running smoothly.
Precisely. Think of it as giving your database some breathing room.
I like it.
Now, another scenario where the change buffer excels
Yeah.
is when you have a high volume of DML operations. Those are your inserts, updates, and deletes that are heavily impacting those secondary indexes.
So if my database is constantly buzzing with changes to data that affects secondary indexes,
Right.
the change buffer steps in to manage that traffic.
Exactly. It helps prevent those changes from becoming bottlenecks and keep things flowing smoothly.
Okay.
And finally, the change buffer is a true champion when you have a large number of secondary indexes that are constantly being modified.
So lots of data, frequent changes,
Yeah.
and numerous secondary indexes.
Yeah.
That's the trifecta for making the change buffer really shine.
You got it. Those are the hallmarks of a scenario where the change buffer can significantly boost your database performance.
Eh,
Like any tool, it's not always the perfect solution.
yeah.
There are times when you might want to consider disabling it.
Okay, so when would we pump the brakes on the change buffer?
Sure.
When might it not be the best fit?
Well, technology is constantly evolving.
Right,
With
right.
the rise of fast storage technologies like SSDs,
Yeah.
the performance gap between random and sequential reads has narrowed.
Okay.
In the past, the change buffer was crucial for minimizing those slow, random reads.
Mm-hmm.
But with SSDs, that advantage isn't always as pronounced.
So the speedy SSDs have changed the game a bit.
Absolutely.
Mm.
If your entire data set fits comfortably in memory because you have enough RAM, or if you're using super fast SSDs,
Right.
the benefit of using the change buffer might be minimal.
So it's like having a super efficient delivery service when you only have a few packages to deliver.
Yeah.
You might not need all that extra optimization.
Exactly. Or if you only have a handful of secondary indexes. The overhead of managing the change buffer might outweigh its benefits. It's all about weighing the pros and cons based on your specific setup.
So smaller data sets, fewer indexes,
Right.
and the use of SSDs.
Yeah.
Those are the key indicators that disabling the change buffer might be worth considering.
Yes. And in fact, in MySQL 8.4 and later,
Okay.
the change buffer is disabled by default due to these hardware improvements.
Wow. So MySQL is adapting to the evolving hardware landscape. That's pretty cool. Now, I want to dig into some of the frequently asked questions from the article, because
Okay.
there are a few that I think our listener will find really insightful.
Right.
One that jumped out at me is, what is the benefit of the InterDB change buffer?
Okay.
I like that they put that in all caps.
Yeah.
It seems very important.
At its core, the benefit is all about efficiency. As we've discussed, the change buffer minimizes those costly random I/O operations,
Right.
leading to faster write speeds and improved overall database performance.
Yeah.
It's like taking the express lane instead of getting stuck in stop-and-go traffic.
And that leads to a smoother, faster experience for anyone interacting with the database, right?
Exactly. Now, another question that often comes up is,
Yeah.
does the change buffer support other types of indexes?
Ah, yes. This seems like it could be a common point of confusion.
It is. It's important to clarify that the change buffer is specifically designed to optimize secondary indexes.
Right.
It doesn't work with other index types.
Good to know. So if
Yeah.
you're relying on other types of indexes,
Right.
the change buffer won't come into play.
Precisely. Now, for a question that I think will resonate with our listener as they consider their own database optimization strategies, when should the change buffer not be used?
Okay, let's talk about the situations where the change buffer might not be the right tool for the job.
We've touched on some of the key scenarios already. Smaller data sets that fit comfortably in memory systems using SSDs, where random read performance is less of a bottleneck.
Okay.
To cases where you have very few secondary indexes.
Yeah.
But there's another interesting point mentioned in the article that's worth highlighting.
Right. What else should we be watching out for?
The article mentions that if you're seeing a lot of contention reported in engine InnoDB status due to mutex weight on ibobuf.cc,
Okay.
it could be a sign that the change buffer is actually causing more harm than good.
So it's not always a silver bullet, right?
Right.
We need to monitor our systems and be aware of potential issues.
Exactly. If you see that specific message, it might be a sign that the change buffer is creating a bottleneck, and it might be beneficial to disable it.
So it's about understanding the trade-offs, monitoring your system, and being ready to adapt your strategy if needed. This deep dive into the change buffer has been incredibly illuminating.
It really has. We've uncovered its inner workings, explored when it's most effective, and learned about the situations where it might not be the best choice.
We've covered a lot of ground in this first part. But we're not done yet. Stay tuned for part 2 of this deep dive, where we'll delve into even more frequently asked questions about the MySQL Change Buffer.
We'll uncover more insights and practical tips to help you make the most of this powerful feature. See you in part 2.
All right.
Welcome back to the deep dive.
Yes.
Let's jump right back into those FAQs about the MySQL Change Buffer.
Okay.
Remember, these are designed to help you apply what we're learning to your own database work.
Perfect. I'm ready for more.
Okay.
One of the questions that stood out to me is, what types of operations modify secondary indexes? I think understanding this will help us see the change buffer in action.
Absolutely. It's important to remember that any operation that changes data in a table can potentially modify secondary indexes as well.
Okay.
This includes those common actions: insert, update, and delete. If the affected index page isn't already in memory,
Okay.
the change buffer steps in to handle those modifications efficiently.
So it's like a safety net. It makes sure these index changes are taken care of even when the database is juggling other tasks.
Exactly. It prevents those modifications from becoming bottlenecks.
Right.
This leads us to another interesting FAQ. How much space does InnoDB use for the change buffer?
Yes. This buffer can't be infinitely large. There have to be some limits on how much space it can take up.
You're right. The space allocated to the change buffer is configurable.
Okay.
There's a parameter called InnoDB Change Buffer Max Size that lets you control how much of the buffer pool could be used for change buffering.
What's the typical range for this setting? Like, what are the defaults?
Right.
And what should we keep in mind when adjusting it?
By default, it can use up to 25% of the buffer pool size.
Okay.
You can adjust this value up to 50% if needed.
Okay.
It's about finding that sweet spot where you're giving the change buffer enough room to work,
Right.
but not starving other database operations.
So it's a balancing act. We want to give the change buffer enough space to be effective, but also ensure other database operations have the resources they need.
Precisely. Another FAQ that sheds light on the change buffer's internal workings is,
Okay.
when does change buffer merging occur?
Okay, let's get a bit more technical. We know changes are stored temporarily in the change buffer.
Right.
When are they actually applied to those secondary indexes?
It happens when a page containing the relevant secondary index is read into the buffer pool.
Okay.
That triggers the merging process. The changes from the change buffer are applied before the page is made available for use.
It's like a just-in-time operation. The changes are only applied when they're actually needed.
Exactly. This ensures the data in the secondary indexes is always up to date when it's accessed.
Gotcha.
And importantly, this merging is handled as a background task.
What does that mean exactly? Like, it's happening behind the scenes without interrupting other operations?
Precisely, InnoDB handles it independently, so it doesn't interfere with other database activity. It's like having a dedicated crew working behind the scenes to keep things running smoothly.
Love that analogy.
Yeah.
It makes it so much easier to visualize. So speaking of this behind-the-scenes work, another question that came up is, which parameter controls the I/O activity for change buffer merging?
That would be init bio capacity.
Okay.
It sets an upper limit on the I/O activity for background tasks, including change buffer merging.
So we can control how much I/O the merging process is allowed to use.
Yep.
We can prevent it from hogging resources and impacting other database operations.
You've got it. It's another level of control for performance tuning based on your hardware and workload. Now, let's shift gears and talk about durability. One of the FAQs asks, is the change buffer durable?
Durability is essential in a database. It means that even if the system crashes, we don't lose data. So what about the change buffer?
Yes, the change buffer is fully durable.
Okay.
The changes stored in the change buffer are not lost.
Okay.
Even if there's a system crash, they're written to the redo log, which is MySQL's crash recovery mechanism.
Okay, so it's not some temporary storage that disappears if things go wrong. These changes are persistent.
They are. Even in the event of a crash, they're preserved and reapplied during the recovery process.
Okay, so.
Speaking of crash recovery, another question asks, when is change buffer merging performed during crash recovery?
That makes sense. The database needs to get back into a consistent state after a crash. So where does the change buffer fit into that?
During recovery, the changes from the change buffer are applied to those secondary indexes as the relevant pages are loaded back into memory. This ensures that the indexes are up to date and reflect the state of the database before the crash.
So it's a key part of restoring the database to how it was before the crash.
Right.
It sounds like there are specific mechanisms to manage these merge operations even after a restart.
Absolutely. The system is designed to resume those merge operations smoothly. making sure everything stays consistent. And for those times when you need more control,
Yeah.
you can actually force a full merge of the change buffer.
Oh, interesting. So there are situations where we might want to trigger a full merge manually.
There are. The article mentioned that you can force a full merge during a slow server shutdown
Okay.
using a specific option, INV fast shutdown.
So that gives you more granular control over the merging process if needed. Now, another term that pops up is flushing the change buffer.
Right.
What does that mean exactly?
Flushing simply means writing data from memory to disk
Okay.
for the change buffer.
Yeah.
Updated pages are flushed using the same mechanisms that handle other pages in the buffer pool.
So it's not treated any differently. It follows the same rules as any other data that's being managed in memory.
Exactly. It's seamlessly integrated with the buffer pool's flushing mechanisms.
Okay, cool.
So we've covered a lot of technical details about how the change buffer works, its components, and the parameters that control its behavior.
Yeah.
But let's step back and look at the bigger picture again. When is the change buffer truly beneficial?
Let's recap. When should we be thinking, yes, the change buffer is the right tool for this job?
The change buffer shines when you have a few factors working together.
Okay.
First, when your insert, update, and delete operations heavily impact secondary indexes.
So if those indexes are constantly being hit with changes,
Right.
the change buffer can help manage that traffic flow more efficiently.
Exactly. And second, it's especially helpful when your data set doesn't fit entirely in memory.
Right.
The change buffer acts as that temporary holding area,
Right.
reducing those more expensive disk operations.
It's like that overflow valve we talked about earlier. It
Yeah.
keeps things running smoothly even when memory is tight.
Precisely. Those are the prime situations where the change buffer can significantly boost your database's performance. But as with any tool, knowing when not to use it is just as important.
So let's talk about those situations where we might want to reconsider using the change buffer.
As we've discussed, the rise of SSDs has changed the game.
Right.
If your entire data set fits in memory or you have relatively few secondary indexes,
Yeah.
the benefits might not outweigh the overhead.
So it's like having this powerful tool in your toolbox.
Right.
But sometimes a simpler approach is sufficient for the task at hand.
Precisely. And even with SSDs,
Yeah.
remember that excessive contention on the change buffer can actually indicate that it's doing more harm than good. Monitoring your system is key.
That's a great reminder. Always monitor and be ready to adjust your strategy if needed. This deep dive into the change buffer has been incredibly insightful.
It really has. We've uncovered how it works,
Right.
explored its strengths and limitations, and hopefully give you some practical takeaways.
We've still got more FAQs to cover. Are you ready for part 3 of this deep dive?
Absolutely. Let's keep exploring this fascinating feature.
We're back for the final part of our deep dive into the MySQL Change Buffer. You've sent us some fantastic material to work with, and I have to say, I'm really starting to see how understanding this feature can help you fine-tune your database performance.
Yeah, it's one of those things that once you understand how it works, can really change how you approach optimization.
Absolutely. Okay, so we've covered a lot of ground already. What other FAQs from the article do you think we should tackle?
There's one that's quite practical and might help you visualize how the change buffer operates.
Okay.
The question is, how does the change buffer relate to the merge operation?
Okay, so we're connecting this back to a specific MySQL operation. This should be interesting.
So the merge operation in MySQL is used to combine multiple tables into a single result set.
Right.
It's important to note that the change buffer doesn't directly interact with this operation.
So it's not like the change buffer is somehow merging data during the merge operation itself.
Right. The change buffer's role is focused on optimizing those secondary index changes from insert, update, and delete operations.
Okay.
It's a separate mechanism that operates independently of the merge operation.
Good to know. So if you're using the merge operation, you don't have to worry about the change buffer interfering with that process. It's doing its own thing in the background.
Exactly. Now, another question that might be on your mind is, does the change buffer improve performance for queries that only access primary keys?
Ah, yes. This gets to the heart of how the change buffer actually works. We know it's all about optimizing secondary indexes.
Right.
So what happens when a query focuses solely on primary keys?
In those cases, the change buffer isn't involved. Remember, its primary function is to optimize changes to those secondary indexes.
Right.
If a query is only looking at primary keys, it bypasses the secondary indexes altogether, so the change buffer doesn't come into play.
That makes perfect sense. It's like having a specialized tool that's designed for a specific purpose. If you're not working on that specific task, you wouldn't need to use that tool.
Exactly.
Yeah.
And this leads us to a related question. Does the change buffer help when doing bulk inserts into a table?
Okay, bulk inserts. We're talking about adding large amounts of data at once.
Right.
Does the change buffer play a role here?
It can, but there's a nuance to consider. When performing bulk inserts, especially using tools like load data in file, MySQL often bypasses the change buffer for performance reasons.
So in those bulk insert scenarios, MySQL might decide to handle those secondary index updates differently.
Exactly. It might choose a more direct approach to optimize for the large volume of data being inserted. It's like choosing a different shipping method when you have a whole truckload of packages to deliver.
That's a great analogy. It helps to understand why MySQL might make those adjustments for bulk operations.
Now, here's a question that gets to the heart of why we might want to disable the change buffer in some situations. What are the potential drawbacks of using the change buffer?
All right, let's talk about those potential downsides. We've hinted at them throughout this deep dive, but it's important to understand the trade-offs.
So one potential drawback is increased memory usage.
Okay.
The change buffer does require a portion of the buffer pool, and in some cases this could lead to less memory being available for other critical database operations.
So we need to make sure we're striking the right balance between allocating enough space for the change buffer and ensuring that other operations have the resources they need.
Exactly. And then there's the potential for contention, especially if there are multiple threads trying to access the change buffer simultaneously.
Right.
This can lead to performance bottlenecks.
So if there's a lot of activity happening around the change buffer, it could actually slow things down instead of speeding them up.
Exactly. It's why monitoring your system and looking for those signs of contention like that mutex wait we talked about earlier is so important.
It all comes back to monitoring and understanding the dynamics of your system. Now, before we wrap up this deep dive, I want to make sure we leave our listener with some actionable insights. If someone is listening to this and thinking, okay, I need to take a closer look at the change buffer in my own MySQL setup, what are the key things you'd recommend they do?
First, analyze your workload. Are you dealing with a large data set? Do you have a high volume of DML operations impacting secondary indexes? These are the scenarios where the change buffer can be a game changer.
So start by understanding the characteristics of your database and the types of operations that are happening most frequently.
Absolutely. Next, consider your hardware.
Yeah.
Are you using SSDs? If so, the benefits of the change buffer might be less pronounced.
Okay.
You might even want to experiment with disabling it and see if it improves performance.
So don't be afraid to test and see what works best for your specific setup.
Exactly. And of course, monitor your system closely. Keep an eye on those performance metrics and look for any signs of contention. Tools like Show Engine InnoDB status can be invaluable for this.
Always be monitoring. It's the key to staying on top of potential issues and making informed optimization decisions.
Well said. Understanding the change buffer and how to use it effectively can be a real asset in your MySQL toolkit.
This deep dive has been so insightful. I think our listener is going to walk away with a much deeper understanding of the change buffer and how to leverage it to boost database performance.
It's been a pleasure exploring this topic together.
Your curiosity inspires us to keep diving deeper into the fascinating world of databases.
Until next time, happy optimizing.